Hello everyone, welcome to the week 2 live interaction session of field structure geology. I am Rajiv Ranjan and I will continue for the next couple of weeks with you all. So I hope you all have watched week 2 lectures. So last week we had discussed the introductions part, tools, field locations and measurements and plotting the data. Today we will be discussing week 2 where we have learned about primary and secondary structures and basically the structural mapping. So let me give you a brief summary of the week 2 lectures. So we have covered in the lectures about primary structures where we have learned bedding planes, cross beddings, overturned cross beddings, which is used to determine younging directions. Also for the primary structures we have learned that it is used for paleocline directions. For example, ripples, migrations, convoluted structures, load balls, dash, and pillar structures. We also saw in one of the lectures how to construct a fracture plane from traces. Traces of what? Traces of bearings or fractures. Then in the last couple of lectures, you learned about secondary structures where you have learned cleavage refractions, different types of cleavages, cleavage bedding intersections, granulations lineations, pressure shadows, mineral lineations, and overprinting lineations. So today I have covered some basic problems from all these topics, and while we will go through the problems, you will revise the lectures of this week too. So if you have any questions, any doubts in between the sessions, please raise your hand or you can unmute yourself and ask your questions. I hope I am audible enough to you all. Hi Sumit, can you hear me?
Yeah, I can hear you, but
Okay,
presently I don't have any to know. Actually, I have to go back to a very basic thing. So I am quite frightened whether I should ask this or not,
okay,
because the
no issues.
problem is that I very attentively followed your discussion on strike and deep, but the basic idea I couldn't get. Actually, I am not from this field, so it may be
Okay,
one of the reasons. I am following a book also.
okay. So
So
did you watch lectures of week 1?
yeah. I have watched. I just fail to understand. Is there any mathematical connection between strike and deep angle? I mean, given the deep angle, this should be the strike. Some interrelationship like
No,
that.
no. Okay. So if you, I guess you didn't appear for the last week live interaction session, right? You were not there, right? In the last interaction session.
Hmm.
Yeah. So there I discussed about you know uh, the deep directions. So basically about the attitudes of lineations and foliations, basically planar and linear features. So there I taught and I discussed with all the students that okay, so you have basic idea about the attitudes, right? Attitudes of planar and linear features, right? So okay, so if I ask you what do you measure in planar features, what are the measurements that you take to study planar features, such as if you have a bed, if you go to a field and if you saw a bed, so what are the measurements that you take in general? Sumit, can you follow me?
Mainly altitude. Alt, I mean, what is the elevation from the plane? Something like that. Are there
Okay,
any folds
okay,
present? Are there any folds present?
okay, okay,
And
okay.
also the morphology of the structure.
Okay, okay, Smith, tell me what is your background?
I am quite senior, and I am from mathematics. My basic I mean field is mathematics. So
Okay, okay,
I
okay,
am
okay.
quite new to this field. I am
So
interested in this
how
matter.
did you, okay. So did have you taken any course? You just have taken this course, NPTEL course. You have not studied anywhere, right?
No. Only not in geology. In NPTEL course, I am quite familiar, and I have got. I mean, I've done several courses. I have got certifications also. But so far as geology is concerned, this is just a first step I am making,
Okay, okay,
and
okay.
I
No
think
issue, Smith.
I have.
I will try my best to make you, you know, understand some basic idea about geology and this, drip strike bed. Okay. Uh, mm, I will do one thing. You can see right my screen.
Yeah, yeah, yeah. Right.
Okay. Okay. Good. So, okay, we have mainly two features, right? Planar and linear features in the field. Basics, very basics. In planar, what we see, beds, mainly beds, right? In linear, we see lineations, such as, what are the lineations? Do you know? For example, mineral lineations. Hmm. Mineral lineations. You see striping lineation, which I will discuss today in the lectures. Striping lineations. You see intersection lineation. Very basic. You see fold axis. You know fold axis, right? When you have a fold, for example, you have a fold. No? Suppose you have a fold. No? You have fold. So this is known as your hinge line. And parallel to this, all this line, this is known as fold axis. So you can see lineation means linear features. So for beds, for example, suppose this is a block and the bed is, there is a bed. If you can follow the bed here, so in the cross section you can see. So I will just draw another bed here. Let me, suppose you are looking at cross section. Hmm, and this is the, bed. So to make a very basic, giving a basic idea, suppose the red markings is the bed. Hmm. Of course, so if you see, so this will be a bed. Sorry. So if you try to measure this bed attitude, so we measure three things. First, strike. Second, dip amount. And then third, dip direction. So if you can see, so this is the three measurements that we take in a planar features. In linear features, we measure trend and then we measure plunge. and there is some another features which we will discuss later. So strike is what? The bed which makes, if I draw a very hypothetical horizontal, considering this as a horizontal, so the intersection between this bed and this horizontal plane, if you see here, so this green line will be your strike, and with the horizontal, that angle which makes, you know with the bed, the angle which the bed makes with this horizontal is known as dip amount. Dip amount. What is the dip direction? Where in the direction in which the bed is dipping. Bed is dipping. So if you imagine here, this is north, this is south, this is east, and this is west. So if you try to follow here, so I will just consider to make it very, easier. I will consider this is north, this is south, this is west, and this is east. So you can see this bed is dipping towards which direction, Sumit?
Southeast.
You can say southeast. But if I'm considering this as a strike, then you can directly say this is dipping towards east. It looking like it's southeast, but if I'm considering this as north, then you can say it's dipping towards east, right?
Okay.
So these three basic things that we measure in a planar features. I hope you understand dip direction is strike, right?
Yeah, yeah, yeah.
And in linear features, we measure trend and plan. So suppose suppose you have the same bed now, but what, you can have some lineations, right? Like this, like you can have some, some basics ideas, like when two blocks will move against each other, there will be some lineation, right? There will be some scratches, right? Suppose very basic stuff I'm telling you. So there will be some lineations here, these markings, linear markings. So this is known as lineations, or if you specifically talk about on the fault surface, this lineation is called slicken lines. So what you can measure, you can measure the direction in which this is, pointing. So this is called trend, and the amount, again I'm telling you, is very similar to dip. The plunge amount is very similar to dip. So the angle that lineation is making with this horizontal is known as plunge. So mainly two things this we measure in linear features. There is one important, I won't say that much important, but there is one other features that we measure. There is one other attitudes which we take, is called rake. Rake is what? Rake is rake, or we also called it pitch. So this is measured with respect to the strike of the bed to the lineation. So on the fault plane. So this is measured on the fault plane. Remember this. So this is measured on the fault plane, rake or pitch. So this angle on the fault plane is called rake, yeah, pitch. And remember that this dip amount or plunge amount is measured in a vertical plane. The angle which we are taking from vertical to this, if you can see me, so if suppose this is a horizontal plane and this is the lineation, so you are measuring this angle on a horizontal plane. So this angle will be your dip or plunge. In case of lineation, this will be plunge. In case of plane, this will be dip. I hope now basic is clear, right, Sumit?
So actually, this much I understood. But the problem is that I just fail to understand that how can strike have I mean two measurements. Uh, what I what I am guessing that there is a line and the angle above that line is 180 degree.
If you have dip direction, If we have dip direction given, you can add or subtract 90 degree, then you will get the strike. But according to a rule which is called right hand rule, right hand rule, right hand rule, based on this, if you have what, if you have a dip direction given as suppose 090, which is east, then if you add 90 degree plus 90 degree, so then you will get 180 degree, which is south. So there is a relation between strike and dip direction. There is no relation between dip is basically amount of this inclination, how inclined your bed is. So that is a different, that is based on the geological conditions. I mean, that is, there is no relation about the amount of dip. That is about the tectonic forces that we don't know. We here we are not considering. We are only looking at this present scenario. And about your question about strike, so if you can see here, so this is the strike. If I make it here, so if you talk about this bed strike, so this is the strike. If you consider, so you can see there is a two direction, right? This and this. So that is why if you plot strike, so this is how we plot. We first make the strike, so this will have two end. So the bed will always have, if you consider this as a bed, so this point and this point will always have two directions, right? 180 degree. So this is how we, this is how the convention is. The geologists have made this convention, so you cannot do anything. So if suppose this is 45 degree, then you simply add 180 degree, right? 225, right? Okay. So I would request you to go to the lectures and please make sure you watch it. If you don't, if you still have confusions, please drop your questions in the forum, or you can even ask during the class next session as well. Okay, Sumit,
Okay,
should you
okay, okay,
should you
okay.
proceed now? Now try to
Yeah, yeah, yes.
engage here, so you will understand, huh? You will understand. Okay. So this is very question, very basic question. What is the primary structure in geology? Option A, features formed by tectonic processes, featured formed during sediment depositions, features resulting from metamorphism, or features formed by erosion. What do you think? So there are two types of structures that,
It should be option A, tectonic process.
so there are two types of, there are two types of, I will here, I will, hmm. So there are two types of structures. Hmm. First, primary, second, secondary. Primary is, it's very natural deposition. So it is based on sedimentation, you can say. There is no forces, formed when sedimentation processes, or you can say deposition. There are, an important thing is no mechanical forces applied. Hmm. But in case of secondary, this is a result of tectonic forces. For example, if you talk about secondary, so example is what? Foliation, fold, falls, etc. If you talk about primary, example would be what? Bedding plane. Another example is what? Cross beddings. And there are several other beds. So this is due to natural depositions. So if you talk about primary structures, so you can see here features formed during sediment deposition, features resulting from metamorphism. No metamorphism is required for primary structures. Remember, primary structures only formed during depositions. So sediment depositions formed by erosion. No, not erosion, because this is a mechanical process. tectonic forces, no, tectonic processes is not applied to primary structures. So that is why option B is correct. Okay, understand?
Actually, I was thinking it in terms of primary rock and secondary rock kind of. I mean, so
So
my back. I don't have any geology background. That's right.
it's okay, it's
Okay.
fine, it's fine. You will get some ideas, and it's interesting. You will learn gradually. You cannot expect, in one day you will learn, right? So you need to give some time. Okay, so next question is, what type of lineation is formed by the intersection of two foliation planes? So suppose here the question is asking that what sort of lineation will form when you intersect two foliation plane. So if you have not studied, so in general, if two foliation plane intersects, granulation lineation is something which is not at all related to this. Okay, so primary lineations is not. So it's simply, if you see here, it's saying that when two foliation plane intersects, huh, so you have to see that, if you have to understand what is this foliation plane. So I will just draw one example. I will just draw this plane. So suppose you have a plane. mm, how should I show you? Okay, so granulation lineation is something. Okay, I will just plot on this. Suppose this is a stereo net. Sorry, my drawing is terrible. Please bear with me. So if you have a two foliation, suppose this is north, this is south, this is east, this is west. Suppose you have two planes, plane A, foliation plane B. Hmm. So the intersection would be some. This will definitely, when two foliation plane will intersect, there will be a fold generation, and this fold and this fold will have some, you know, some hinge. So this hinge line will be what? And if you take parallel to this Yani line, if you take parallel to the hinge lines we discussed right now, this would be what? Fold axis. So here question is saying that if you intersect two foliation plane, so what will form? Granulation lineation is something which is formed when there is a generations of fold, means generation of deformations. So if you have, suppose, two sets of deformations, then if you have the primary, so for example, suppose that S0, S1 and S2. So you have S0 as primary wedding or primary foliation. Yes, Tejas, please. Tejas, do you have any question? Can you
No,
hear
sir.
me? Yeah. Tejas, can you follow the question here? No? Okay. So primary lineation is nothing to do with this foliation planes, since it is a lineations. There will no primary lineations, because foliation planes forms after deformation. So there is some deformation involved, metamorphism or some deformations is involved. So there is no primary thing is there. So this is not correct. So either crenulation lineation or striping lineation. So we know that striping lineation is what? When the plane, so suppose this is the cleavage plane, this is the cleavage plane of this S node. So this is S node, this is S1. So S1 got folded and then lead to formation of S1. So what will happen? So there will be number of bits, right? Like this, like this, like this, and like this. So what will happen here? So there will be generation of this. The moment it intersect with this S1, there will be something like this, right? So here we are looking at S node surface. But here if we look at it, we are looking at a, so if I take out this, foliation S1, and if we try to look at the markings, so the intersection S1 and S node. Huh. So intersection of S node on the S1, this markings is known as striping lineation. And the crenulation lineation is what? Tejas, do you know what is crenulation lineation? So crenulation lineation is something which forms due to what? Can anybody tell me? Anybody?
Pressure of overlying rocks and overlying structure.
No, no, no. So this forms by a process. So it's like if you have a continuous, continuous deformations, continuous shearing. So the original, foliations get realigned, and this leads to formation of something like structures. Huh? So suppose this is your initial. So there is, like this, there is a stress condition. So what will happen? So there will be, so there is nothing is, so point here is I will not take much time, because here I will go in the other further questions. I have, several other questions related to coordination. So here I will get to the point. So here there is no relation, there is no connection of two foliation planes. So two foliation planes only related to this striping lineations, because when the only two foliation plane intersects, then only lead to form of striping lineation that we saw here. But crenulation lineation is nothing to do with two foliation intersection. It's only due to deformation, continuous deformation stage. Okay, so that is why option C is correct. So next question, moving to the next question, which of the following is not a characteristic of primary structures? Option A, formed during sedimentation. Option B, reflects depositional environment, results from tectonic forces. And option D, can be observed in sedimentary rocks. So remember, which of the following is not a characteristic. So choose which is not a characteristic of primary structures. Tell me,
Sir,
Tejas.
here it should be C, option C, I think.
Yeah, right. Very good.
So
Tejas.
actually, the problem is that I don't have any basic, I mean, grounding or I mean, foundation in geology. And so whatever I am thinking about it, whatever I was thinking about it, is that on the basis of my knowledge of geography, whatever primary knowledge I had of geography. Here you are talking about this tectonic forces. I take tectonic forces to be primary, and sedimentary forces to be secondary. But here I am getting a different idea. Yeah, yeah. Mm.
So I would suggest, there are so many courses you can go and, take a course which is very basic structural geology. So there is a structural
That
geology
is one
course.
mistake I have committed. I shouldn't have
Uh,
joined these courses. This is much more
uh,
advanced. Yeah, yeah.
yeah, so you should have taken the first basic courses of structural geology, then you take these courses or other geology courses, because that will give you very basic
Problem is that I
fundamentals
have
of.
already applied for the exam.
It's
Okay,
okay,
no
it's okay,
problem, no problem. Whatever
it's
I
okay.
get to learn, that is enough. That is good
Yeah,
for me.
good, 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 good. Okay, move to the next question. How do secondary structures differ from primary structures in sedimentary rocks? Option A, secondary structures are formed during deposition, while primary structures are formed later. Secondary structures result from tectonic processes, while primary structures are original features. Secondary structures are always larger than primary structures. Option D, there is no difference, they are the same. Again, the same problem. Tell me.
In my opinion, it should be option A. Secondary structures are formed during deposition, while primary structures are formed later.
But now we have discussed a lot, right? You correctly told that primary secondary structures are a result of tectonic forces, and while primary structures are original features. So option B is correct, not option A. Right?
Okay, okay, okay.
Yeah. I hope this is clear. Secondary structures are always larger than primary structures. This is nothing. There is no difference. There's a no. This is not wrong. Secondary structure formed during deposition. No, it's just the opposite. So option B is correct. Which of the following is a primary structured formed by the deposition of sediments in a high energy environment? Tejas, can you answer this? So ripple marks forms in marine environment, right? Or so in marine in coastal areas, if you see coastal areas, the energy is very low, low energy. But if you talk about mud cracks, there is mud cracks is nothing to do with energy or environment. We know very tight, very normal situation. Just because of the heat, mud cracks forms, the desiccation cracks. So there is very low energy here also. Graded bedding is something. Okay, I will go here next later. So slump structure is what? It's related to thin sedimentary structures. Huh. So what happens during thin sedimentary structures? It forms before lithification and after deposition. So due to some disturbance, some shaky movement, something, some disturbances before lithification, so those are formed are called. There is a larger term we call it pene-contemporaneous structure. So one of them is slump structures. So graded bedding is something, suppose you have a profile, uh, a profile. So this is surface, and this is you are going to deeper side, depth. So suppose you have very larger grains, then is smaller, then very smaller. So this is called graded beddings. Or there will be reverse case also. There can be larger grains in the lower part, and then finer grain, then finer grain, then finer grain. So this grading happened because of very high energy. There is shaking, there is earthquakes. So because of that, this graded beddings forms. So that is why the deposition of sediments in a high environment grading is one of them is graded bedding. So graded beddings structures forms during high energy movement. I hope this is clear. Let's move to the next question. Which of the following is primary structures formed by deposition of sediments in a tidal environment? So now the question is, in a tidal environment, what sort of structures do you expect?
This I think the ripple marks.
Mm-hmm.
Should it be ripple marks?
Uh-huh. Think a little bit odd. There is another option here also. You have to think.
If that is wrong, then it should be herringbone crossbedding.
Hmm. Very correct. So I just will correct one thing. So the last question. That is why I'm thinking that you are saying this is ripple marks. So okay, I will just make a small correction in the last question. What I said, this ripple marks is not only about marine environment. It's about directional flow. Huh? It can form in what in aeolian features due to wind. Also, the ripple marks will form ripples.
So can't it be formed due to the action of river? I mean,
Yes, it can form. So there is structures called south side, lee side. So this is possible that you can form through rivers. But rivers has a different scenario. You have to see the location we are looking at in the river. So here, herringbone cross bedding is famous. You know for what? It has. Do you know why it is very special? Herringbone. Anybody?
is it because
No.
the structure is covered? I mean, the formation is quite irregular.
So what happens during herringbone? So first, suppose So initially at time t, maybe from time t naught. So during certain interval of time, suppose the direction is such. So due to that, the cross bedding forms. So this is telling us that. But after some time, what happens? The direction changes. So what will happen? Or you can simply say like this, or like this, or like this. So due to the bi-direction, I won't say bi-direction, due to the change in the movement of the flow is herringbone structures, and herringbone structures has both the direction. One for some certain period of time this is forms, and for after some time, after some time the changes, the direction of this flow changes, and then this herringbone forms. And ripple marks, can you hear me?
Of course, yeah, yeah. Please go on.
I'm not able to hear you. Can you hear me? One
I
second,
can
one
hear
second,
you, sir.
one second, one second, one second. So what happens, we know tide. Now I can hear you. So in a tidal environment, the flow changes after some time. We know tides changes. So that is why this herringbone cross bedding forms due to the changes in this movement of the direction. So graded bedding is, again, this is not related to tidal bedding. Mud cracks is not related. Ripple marks is not related to tidal environment. So tidal environment is very famous for herringbone cross bedding. Okay, so if you have been through the lectures, so in the field area, present study, so how many quadrant band is there in the field area? So if you have watched the lectures, have you watched the lectures, Sumit?
No, only one lecture is left. One.
Okay,
I have to.
so
I'm yet to hear it.
if you, I will just go through. So there are three bands, quadrant bands in the Ghatshila region, in that Galude, and there is variance in the thickest study area. So there is a thickest, smallest. So there is a variation in the thickness of the band, quartzite band. So here the question is, which band is the thickest in the study area? So this is option 3. So I will just show you the diagram. So this is the image that I have taken from the lectures. So if you see, the first band is going like this, and second, such as second like this, and third is this. So we can see there are three quartzite band, 1, 2, and 3. And we can see the quad band 1, you know this band 1 is the thickest, and band 2, band 3, so the thickest is 1, band 1. Okay, next question. What is the term used to describe the principle of sedimentary layers are deposited in a manner where the oldest layers are at the bottom and the youngest layers at the top? Option A, principle of horizontality, principle of superposition, principle of cross-cutting relationship, and D, principle of lateral continuity. So the question is asking the oldest layers at the bottom and the youngest layer at the top. So which of these principles or the term is used to describe this? So lateral continuity talks about the lateral variation. In a lateral variation, suppose from here to here, so there is a continuity. Until unless there is some barrier, this bed will continue in both side, here and here. So this talks about lateral continuity. So there is no oldest layer at the bottom and top. So this is not. Cross-cutting relationship is something which says that, no, suppose you have a bed and there is a bed, one bed, like this. There is another bed which has a different attitude. I'm just change. So the one which cuts the other ones is the, so here we can see the red one is younger because it is, red one is red one is cross cutting which the green one. So the red one is younger and the green one is older. So principle of cross cutting resistance tells us the one which cuts the other is the younger and which got cut is the older. So this is also not related to depth. So principle of superposition is something which deals with, it tells us that the oldest layer will be at the bottom and the youngest layer at the top. And this is something which is asking the question. And principle of horizontality says that the deposition happens, and if any deposition is taking place, sedimentation, this will deposit in a complete horizontal manner. So here the question is related to principle of superposition. Okay, so will we move to the next question. In the context of primary structures, what is the significance of recognizing the facing direction of sedimentary structures? So why in this importance, what the direct younging direction, why it is important? Option A, it helps in identifying the mineral composition of the rocks. It indicates the direction of the sediment transport and the way up in a sequence. It provides informations about the age of the rock. It is used to classify the rock type. So facing direction or younging direction is important for what? It gives us the way up sequence. You know, it's nothing to do with mineral composition. Any type of any composition can, deposits anywhere, and that has nothing to do with facing direction. That the facing direction is important for way up sequence. It gives us that which has deposited earlier, which has deposited later, so which is the younging one and which is the oldest one. So suppose you have a bed, layer of bed, and we know 1, 2, 3, 4. So one is the younger. So if you have primary structures, suppose such as what? If you have a mud cracks, or we saw what are the primary structures that we see? Cross bedding. Suppose you have a cross bedding. So this is a bed. So this is a cross bedding. So we know this asymptotic bottom is gives that bottom of this bed. So this is a bed. Suppose bed, bed A. This truncated part gives us the top direction or younging direction. So primary structure is important. It is important that because it gives us younging direction or way up sequences. So option B is Correct. It has nothing to do with the age of the rock, because there could be deformation, there could be, metamorphism. Nothing to do with class or rock type. Which of the following best describe the term granulation? Tell me. First of all, option A is sediment. It's not a sedimentary structure. Granulation is not a sedimentary structures. Why? Because granulation forms at least minimum two stage of deformation. So there must be deformation and minimum two stage, second stage of deformation. So option A is incorrect. Type of faulting, there is not relation with faulting for the granulation. In linear alineations found by mineral alignment. No, there is nothing to deal with mineral alignment. I mean, there is, but it's mainly related to small scale folding. Why? I just discussed a couple of slides back that when your primary surface or primary bed, suppose this is your primary bed, gets, so it has, something like this. This gets folded. So what will happen? This will become something like this, right? Something like this. So you will see what, a generation of new. So this is S node and this is S1. And then if this S1 gets folded, so what, how will it look? Something like this. Sorry about the terrible drawings. So this is known as granulations. So this is, granulation is known for what? Very small scale folds. And in a very intense deformation, there could be mineral segregation that happens, that we will discuss in the upcoming slides. So there is in a small scale folding is involved and alineations formed by mineral alignment. No. So that is why, yes, Sumit.
Sir, what is the force behind folding? I mean, what is the
There could
underlying
be
reason?
tectonic forces, right? We know that plates are moving, so depending on the, local and regional stresses condition, they changes, and because of that your forces changes. So sometimes there is oceanic rates, sometimes they become it transform in the millions of years, it becomes subduction zone. So because of that there are several other reasons, physiographic or, tectonic forces changes. Because of that tectonic forces change, and as a result different stress conditions take place, and because of that this forms. I hope clear, right?
Not due to any internal adjustment of rocks or
So that happens because of what? Because of tectonic forces, right? Until unless temperature and pressure is there, tectonic forces is there, there won't be any alignment, won't be any internal reorganization of minerals. This happens because of pressure and temperature conditions.
okay.
Okay, so which one of the following represents bedding planes? I have discussed a lot this, very basic. S naught, S1, B naught, B1. So we represents planes or foliation as S naught, S1, S2, S3. So this is bedding plane or primary bed, primary bedding. And this is S1 and stages of, this will be first stage, results of basically results of first stage deformation, and then this will be second stage, and this will be third stage, and this will continue, it will go and on and on. So that is why we present as S0, S0, S1, S2, S3, S4. We don't represent as B1, B2, B3. So here we have a question about penetrative and non-penetrative structures. So option A, penetrative structures occurs only on the exposed planar surface, where non-penetrative structures occurs throughout the volume of the rock. This is wrong. Penetrative structures occurs throughout the volume of the rocks, whereas non-penetrative structures are only found on the exposed surfaces. This is correct. Both penetrative or non-penetrative structures are only exposed. No, this is wrong. I will tell you why. So penetrative structures means that it is pervasive in nature. It is present in the entire rock, such as what? Such as foliations. This is an example of what? Penetrative structures. But in case of non-penetrative, that is like present only in very locally. It's present locally. For example, what? You have slicken lines. So now you all know that what? Slicken line is present only on the fault surfaces, not in the entire rock. Huh. So this is an example of, so slicken line is an example of what? Non-penetrative structures. Hmm. So that is why option B is correct. Okay, let's move. In a deformed mica schist outcrop, you find S0 foliation surface, S1 foliation surface, S2 foliation surface. Which one of the following options would be correct? Option A, only one phase of deformation. Option 2, at least two phases of deformation with a striping lineations formed by the intersection of S0 and S0 foliations. Or you can say S1. At least two phases of deformation with crenulation lineations formed by the intersection of S0 and S0 foliations. At least three phases of deformation with the striping lineations formed by the intersection of S0 and S0 foliations, and crenulation lineations formed by intersection of S0 and S0 foliations. So we just discussed a couple of slides back that we are seeing what in the previous slide also, S0, S1, S2. Hmm. So imagine you had S0, means primary bedding. This got folded. Hmm. So here we can see axial planar cleavage is there, and this will become S1. This will become S1. So this suggesting, so we have at least, if there is another deformation in this direction, what will happen? This axial planar cleavage will deform, right? So this will give us what? Another set of axial planar, with this will be S2. So if you are seeing S0 foliation, S1 foliation, S2 foliation, that means there are at least two phases of deformation. So option A is wrong, option D is wrong. And we studied that striping lineations found by intersection, not crenellation lineation found by intersection, right? So option B is correct. S node and S node formation. So if you see here, there will be some striping lineations here in on this S1 surfaces, or even if you can see this will be on the S node surfaces. So that is why option B is correct. So remember here, try to remember that we have learned that bedding is a sedimentary process of rock formation, while foliation is a metamorphic process. So I have just kept some slides here to make you understand what we were talking about. Huh. So this is how you can see, with further deformation, you can see very minor folds. So this is because we are seeing this, what we are seeing here. We are seeing a microfold, and these fabrics are symmetric, right? So this is why, that is why it is called symmetric granulation cleavage. But if you see here, due to shearing, the fabric has the fabric is not symmetric, it is like this. So that is why this is called asymmetric or sigmoidal cleavage. So there is another diagram to help you understand. So this was bed is not, you can see that original bedding, primary bedding, and due to this folding, you can see this crenulation axis, hmm, and this is crenulation cleavage, hmm, this this S1. So this was just to show you this crenulation cleavage. So let's move to the next question. Which one of the following sedimentary structures is not used for determining the top and the bottom? So in this following options, which are the structures it is not used for top and bottom to find top and bottom beds? Mud cracks. We studied that mud cracks is useful for top and bottom. Load and flame structures. So load and flame structures is something which is also important for what? Top and bottom. You know, so if you have layers, suppose initially you had this layer, hmm, so due to some shakings, hmm, what will happen? The denser materials, what will try to do? It will try to go down. Hmm. And what will happen in the process? This sort of structures will form, and so we can see what we can see here. The bottom part will have this concave shape. So from this we can say that this is the Younging direction. This is the bottom, and this is the top, right? And this happened because of this density differences. Huh. The sand particles, or if you have a sand and mud, so sand will try to go down. Sharp crested wave ripples will not help us. Why? Because, okay, sharp crested wave ripples means like this. So here this sharp crest tells us top, top, top. So mud cracks, we learned that mud cracks gives us top bottom. This gives us top bottom. This gives us plane laminations. What? This is something called plane laminations. So you can see here, with this you cannot tell us. You cannot tell about what? which has the younging directions. So that is why option D is correct, because question asks node used for determining the top and bottom of the beds. Okay, so this is a diagram, this is a symbol. So try to find out which indicates sin form. Option A, option B, option C. What do you think? So what do we know? We know sin form means what? Both the beds are dipping towards each other. Antiform means what? Both of the beds dipping away from it. Right. So what do you see here? You see a bed. You see a bed. And so this is giving you the directions, young directions. Okay. So if you see scene form, if you have layers, you know, so in scene form, what happens is that in the core, if you see here, like this. So here would be younging, so younger ones, and here will be older ones. So in the core the younger ones resides, and in the outer core, in the outer part, this here remains the oldest one. So if you see, this direction is marking what? Towards the q. Basically here this direction is towards the core, is marking the younger ones. Here if you see, away from the core is marking younger one. Here it's up and down, is nothing, is ये तो हो ही नहीं सकता. This one is not possible, right? Option C and D is not at all possible. So option A is the correct option. Why? Because the arrow is marking the younging direction, and we know that in case of syncline or syn form, we have the youngest in the core. Okay, good. Let's move to the next question. Which of the following structures indicates penny-contemporaneous deformation? So I discussed penny-contemporaneous structures. You know what it means. So penny-contemporaneous deformation means that deformation that occurs, deformation that occurs you know during depositions or after deposition and before lithification. So these are known as penny contemporaneous deformation. So if you see here, option A is festoon bedding, option B is convolute bedding, option C is flazer bedding, option D is tabular bedding. So I have just kept some figures to help you understand which is festoon bedding, what is convolute bedding, what is flazer bedding, and what is tabular bedding. So if you see this convolute laminations, so you can see these are the primary structures, this primary. So this forms during depositions, and since it was not lithified, this got very distorted. I mean, you can see there is very random structures. So this is known as convolute structures. If you see flazer bedding, you know, so flazer means you have more sand. So the white part is sand and this is mud. So the muds, this is called flagella laminations. So mud is actually in the matrix of sand. So these are called flagella bedding. And this is not remember, this is not continuous. The flagella bedding is discontinuous. This is not continuous. But in wavy laminations, you will see a continuity. And this opposite happens in case of lenticular laminations, where mud is mud becomes matrix and sand becomes this lenticular type. Hmm. And this is something. So here you can see this mud and sand, percentage of mud and sand. So if you go to bottom part, the mud is increasing. If you go to top part, the sand is increasing. Okay. So this is how you classify the types of laminations: flazor, wavy, lenticular. So remember that wavy is in between. Flazor has more sand, less mud, while lenticular has more mud, less sand. And this slumping is, due to gravity. We know slump happens because of gravity. Suppose you have, inclined, plane. Hmm. Suppose you have inclined plane. What will happen? Suppose this bed is not lithified. So due to this gravity, there will be some structure that will form here. And these are called slump. Folding of number of beds simultaneously due to gravity induced sliding following further depositions. This is something is called as festoon beddings, or this is also known as, can somebody tell me what is this known as? Trough cross beddings, right? We cannot see any continuity. So random. Everything is random. This is random. This is also random. So this random or trough cross bedding, cross trough bedding is what? There is no particular alignment of this beddings, cross beddings. So this is not related to penny-contemporaneous structure. Penny-contemporaneous structure is related to this. This happens after the depositions, or even later period. So festoon is not related to, does not indicate penny-contemporaneous. Flagella bedding, it, if you see, this is not a part of penny-contemporaneous structures or deformations. Tabular beddings, I will just show you another slides. You can see here. So this is the water level. So this is the ripple marks. And later due to the displacement, this has become like, so earlier this was like this, but due to this continuous movement, from here the sediment is depositing and it is moving towards right. So you can see this is going and depositing, this is going and depositing, like this again here. So here you can see different types of cross beds. So there is no variation, you can see parallel lines almost, there is straight linear cross beds. So that is why it is called planar or tabular cross beds. This is not a penny contemporaneous structures. Trough cross beds, you can see asymptotic structures. Herringbone cross beds that we saw earlier also. And sigmoidal cross beds. Here you can see, here you cannot tell us the top and bottom. You cannot, because both of the top, even both on the top and the bottom, we have what? We have asymptotic top and bottom both. And here we have reactivated surface, so the same surface can get basically reactivated. How? Deposition plus erosion plus forest forceps. So if the direction the energy condition changes, this leads to reactivation of the same surfaces. So if you see, planar surfaces is generated by migration of large scale straight crest bed form. Trough cross beds, how did it form? How does it form? It forms by downstream migration of curved crest beds. So what happens due to this way movement, downwards like this trough cross beds forms. And we know, we saw also that herringbone forms due to the reversal in current trend, swash and backswash currents in the tidal environments. So for some time the direction flows like this, and for another set period of time the direction changes in these directions, so just opposite. And this sigmoidal is forms due to clay draped fine sands and laminated tidal sands. So with this you can understand, this only the convolute structures or convolute beds is an example of penny-contemporaneous structures, not flazer, not tabular, not festoon. Okay, so this is something which is related to the lecture. So you have must have, if you have been through the lectures, you will definitely answer this question. So this question says, in an oblique outcrop, suppose you go to a field and you saw what? An oblique outcrop, not very horizontal or very vertical, straightforward outcrops. You find what? You found traces of bedding planes exposed on three differently oriented planes. Suppose, I'm just drawing it. You know, suppose you have outcrops like this from here, then you have something like this here. Again, you go somewhere, you find something like this. Some outcrops. You have a traces of beds. Suppose you saw this is the you are not able to see anything. So this is the beds you saw. Or to make it more easy for you all, I will just draw here. So you have a bed, huh? You have a bed like this, right? Or or something like this. You have bed like this, something like this. But you are not able to see the entire beds. What you are able to see? Only this part, huh? Only this amount of part. So you are able to see in one outcrop. You are seeing only the traces, this much. You don't know what is the deep amount, what is the strike. You don't know. You are only seeing able to see this trend. In somewhere else, in maybe in the other areas, you are able to see like this. So this could be like this, huh? There could be some other variation. So if you are able to see different traces in different oriented planes, then there is a process to estimate the orientation of that bedding planes. So option A says measure the trend and the plunge of the bedding planes, because since you are only getting the lineations, traces, so this will be linear features exposed on each plane. Plot the linear data on stereonet, join the 3 points by approximately a great circle, which will give you the orientation of a bedding planes. Measure the attitude of the three exposed planes. You are only able to see traces of the bedding planes. Plot them in stereonet, plot the pole of the intersection of those three planes, which will give you the orientation of the bedding planes. No. Measure the rake of the bedding plane traces on each you are not able to see the strike, how will you able to measure the rake? Plot the rake values on the stereonet, pass an appropriate grade circle on the bedding planes. You are only able to see the traces. It's difficult to, find the rake. There is no direct method. Wrong, wrong, wrong. So what do you do generally? The method is to, you you suppose you measure L1, L2, L3, three linear features, traces of this bedding plane, of bed A, and then you try to plot. Not suppose L1 plotted here, hmm, L1, L2 plotted somewhere here, hmm, L2, and L3 plotted somewhere, or it can be here, wherever you want. L3 plotted here. So what, after plotting these three lineations, you can what, you can just trace or this following what, greater circle. So this will become your bedding. And once you have these beds, you can easily find out the strike. Hmm, this will be strike, this will be deep amount. So you will have this. So that is why the method is to measure the trend and the plunge of the bedding plane. You trace, then you plot the linear on the stereo net, then join the 3 points in an appropriate grade circle, which will give you the orientation of the bedding plane. So this is how you get what, the orientation of bedding planes from differently oriented planes, traces that is found in differently oriented planes. So remember this is very important. If you go to the field and you're not able to see the beds very clearly, but you're able to see, what, same, compositions, traces in different oriented planes. So you just simply take out the measurement of trend and, plunge of those linear features, and then just plot this trend and plunge on the stereo net, and then you just try to measure, orient in such a way that it lies on a greater circle, and then you can simply get the plane orientation. Okay, so there is a next question. An object is spotted at south 60-degree east. This is north, this is south, this is east, this is west. From the observer, if the position is interchanged, the front bearing value in the degree from north, tell me. So something, it will be like this. Tell me what will be the value. So you are, suppose you are looking, suppose you are looking from the top, and you saw what, you saw an object which is how it is oriented, south 60-degree east from you, from your direction. So suppose you are looking at here, suppose you are here, so you can see the object is here. Now it is saying that the position is interchanged, the front bearing value. Now this person will go here, then what will be the value? Think a little bit. Can you think? So suppose you are looking at an object which is seeing as south 60 degree is. So see, this is 60 degree. This is 60 degree. Now if the position is interchange, how will it appear? Or the position is interchange. If the position is interchange, the front bearing value of the observer what? So it's simply what happens is it becomes 360 minus what will value 300. So it's asking, you know what, the front bearing value from north, and it is measured clockwise. So what will be the value? So this is 60, right? So here the changes. So from here to here, what will value? This is nothing but 360 minus 60, right? This angle will be 60 and this angle is 60. So nothing but this is 300 minus 60. So this is 300. So answer is B. So remember why we made it like that? That it is asking you to measure from the north direction and measured clockwise. So we are moving clockwise, and that's it. So 300. Okay. Fold axis of a regional fold is determined by option A, plotting the poles of the bedding planes, option B, plotting the orientation of joint sets, plotting the foliation data, plotting the lineation data. Tell me. So I will just draw stereographic projection. Hmm. This is north, this is south, this is east, this is west. So think you have plane A, plane B. Hmm. A and B. So this intersection of this A and B will give what? Hinge line, right? So fold axis is determined by, how will you determine? Plotting the poles of the bedding planes, plotting the orientation of the joint sets, plotting the foliation data, or plotting the lineation data. And you know that what? So this is if suppose this is a hmm, this is a fold. So and this is your hinge line. And parallel to the hinge line, all this other will be your fold axis. So now can you think what would be the answers? So you cannot get, because why we have to see as a regional fold, huh? Regional fold follows lineation data. While plotting lineation data, we will not get this fold axis. Plotting foliation data depends that what sort of foliation data you have. Because if you see, so I will tell you about the poles. What is pole? So if you have a bed, if you have bed like this, So the pole is nothing but 90 degree. This is pole 1. If this is A, so this is pole of A. So this distance gap is 90 degree. Hmm. So if you plot all these different beds poles, and this will intersect, and this will what, this will give you a single line. So if you have so many bedding planes, and when you plot poles, it will lie in a very closely, very at one point, very single point, and this will nothing but fold axis. Joints is not giving you you know axis. So the regional fold will have different slight orientation. So but when you plot all this orientation of this bedding planes, and then you plot poles, or of course you can also simply plot the bedding planes, but since you don't have any options here, so when you just plot the poles of the bedding planes, you will get the fold axis, which is this or this. So that is why option A is correct. Or you can simply, if you have bedding data, you can simply plot bedding data. But since we are looking at regional fold, we will have a lot of thousands and thousands of data, so it become very clumsy. So we don't plot generally bedding, we plot poles of the bedding planes, and that gives nothing but the fold axis of these folds. Okay, which of the following represents primary structures? Very simple questions. So foliations is formed by metamorphic processes or tectonic forces. So this is not correct. Pressure side alienation also forms during deformation. Mud cracks, what do you think? Granulation cleavage? No. So what do you think? Which is primary in nature? Think a bit. Think. No? Nobody? Okay. So we know granulation cleavage, we learned a lot. Granulation cleavage is a result of deformation. This is something which we can think that mud cracks, it's very natural process, right? This is primary nature. Pressure shadow forms deformation. Foliations, we generally consider them as form due to result of metamorphic processes. So mud crack is something which there are no involvement of any forces external. So this forms naturally. I mean naturally means this is primary natures. Foliations can be, if you talk about, if you specifically talk about S note, then you can say that is bed, and that will be primary structure, primary nature. But since here it's generalizing as foliations, we cannot consider this. So that is why option C is correct. Okay. Find the correct statement out of the following. Convolute lamina formed by desiccation Broad marks is formed by bottom of a bed. Load cast is erosional structures. Wave ripples occurs at the top of a turbidite deposits. Choose the correct option. I will give it 10-15 seconds to think. Think. No? Anybody? So you can see here, convolute lamellae, we learned is it is a pene-contemporaneous, nothing to do with desiccation. Huh? It's nothing to do with desiccation. Prod marks is formed at the bottom. What is prod marks? Do you know what is prod marks? Nobody? Can you hear me, Sumit? So, okay, I think you guys are not hearing. Okay, you have not guys watched the video. So, prod marks is load cast. We learned that load cast is where does it form? It forms at the bottom, right? So, but it is saying it's erosional load cast. I don't think. Very simple. It's very simple. This is not prod marks forms at the top surface. Huh? Prod marks. Load cast, we know it forms in the bottom part, right? Load cast. So this is incorrect. And we know wave ripple. Where does it form? If you see, if you have a deposit, something like this. No, sorry. So wave ripples. Hmm, so here you have a lot of turbidite deposits. Hmm. And on the surface turbidites, we see ripples, wave ripples. That is why option D is correct. Right? Okay. So next question is match the following. Match the sedimentary rocks with their features listed in group 1 with the depositional environment. Here it will help you to understand. Huh? So try to match this. Okay. So sandstone with herringbone cross beddings, we know what it is, tidal. Chalk with coccolith, poorly. Okay, we'll see here. Well sorted arenite with large cross beddings. Well sorted arenite with large cross beddings. Poorly sorted sediments with faceted with striated pebbles. I think this something actually this pelagic will go not here. This pelagic will go here. Hmm. Yeah. So now try to answer. Try to understand. So if you see here, poorly sorted, huh? This will be sorted. Some mistake is there. Poorly sorted sediments, huh? Poorly sorted sediments. Striated pebbles. This is glacial feature. So we know in glacial we have poorly sorted. It's okay. It's okay, Sumit. It's okay. So poorly sediments with faceted striated pebbles deals with glacial features. Huh? So P4 S2 S2 option B is correct. So now we'll try to understand how. Q5 and R1. If you see here, well sorted arenite with large cross bedding. We generally cross beddings we see in aeolian features, right? And chalks and coccoliths. It's only deals with pelagic sediments. So aeolian. Remember this. Here we find so many sand dunes and all. So all these cross beddings mostly is related with aeolian nature. And glacial, its very characteristic features is poorly sorted, and that is why option for glacial S is correct. So option B is correct. Okay. Another set of following the questions. Match the following. Match the sedimentary structures in group. Match the sedimentary structures in group 1 with the process of their formation in group 2. Flute cast, convolute laminations, rain print, flazer bedding. So we learned that convolute lamination is what? It's a thin sedimentary, right? Okay. So Q4. Remember this. Rain print is what? Rain print is nothing, but it is rain print is what? It is exposed. Then only it will form, right? Rain print. So if you have a surface, hmm, if you open and then it's raining, huh? So when it rains, it forms like this. Hmm. So that is why for rain print this exposure will be so R2. I hope I am clear enough, right? And this flazer bedding we learned what? This happens what? Why this happens? Flazer bedding. We learned in the previous slides, right? We saw you the diagram. We saw show you. I saw you the diagram. Think. So Q4 R2 and if I show you flute cast is something which is related to erosion. Huh? So if you have a surface, hmm, so if there is very high wind, what will happen? We know that it takes off this, it takes out. So the remaining part is like this, or there will be different types, like this, if the wind is like this, or there will be some just take off. So these are due to this erosional in nature. So fluid cause is erosion. So that is why fluid cause this erosion. So P3, Q is 4, Q is 4, R is 2, R is 2. So this is not, this one is the correct option. So option D is correct. I hope this is clear, right? Okay, let's deal with this last question. In the context of cleavage refraction, what does a smaller cleavage bedding angle typically indicate? Read. The layer is more competent and resistant to deformation. The layer is less competent and more susceptible to deformations. The layer has undergone significant metamorphism. The layer is older than surrounding rocks. Remember this bedding cleavage bedding angle. So if you remember, so this is three layers: A, B, C. Hmm. Now they are not all same. So this is, suppose this is sandstone, this is quartzite, quartzite, or you can say this is phyllites. This is phyllite. So this is more susceptible to deformation. Why? Because this is less competent, easily deformable. Sorry, I'm telling you the opposite way. So the less competent will have higher deformations. Hmm. Okay, leave it. So this is A, B, C. So there will be, suppose this is more competent, huh? So there will be less refraction. But suppose this is very uh, susceptible to deformations. This is very weak material. So there will be large, changes in this refractions, and there will be again same. Suppose this is A. So this layer is more competent and resistant to deformation. No, cleavage refractions occurs because there is a change in the competency. There is a contrast in the competency. So that is why due to the layer is less competent. So a smaller cleavage bedding angle, if you see here, so this is the bed, huh? So bedding and this angle is very high, right? In this higher competency, and this lower competency, or if you see this way also, hmm, this is making lower angle. So the higher, the less competent, the layer which is less competent will have, basically they will become more prone to deformation. So they are more susceptible to deformation. That is why their angle is less with the beds. I will show you another diagram. The layer has undergone significant metamorphism. This is wrong. The layer is older than the surrounding. This is nothing to deal with the age. It is only deal with the contrast in competency. This is a image that I have taken from one of the websites. So if you see here, this is the crenulations. This is the parasitic second order folds because of the larger fold. And if you see these slitty cleavages, you know, if you see, if you follow these cleavages, there there is some refraction, right? If you see, this angle is not same as this angle is not same as this. So this angle and this angle is same because of same in the competent. And you can see here there is a fanning. This is called fanning, where the cleavages gets converge. So we can see here the flexure cleavage. So this is, and also if you see this bedding cleavage relationships, suppose you have a bed, you have this lineations, huh? So if you see, the angle is smaller, right? And getting larger in the hinge zone. So there's one beautiful relation of cleavage bedding. So this tells us the smaller angle gives us the direction of hinge. If you see here, suppose you have this pervasive cleavages. So this smaller angle direction gives you towards the hinge zone, and this larger angle gives you away from the hinge zone. So even what we do, we use bedding cleavage relationship to indicate the hinge zone. Okay, so I think I have covered uh, important topics that we have discussed in the week 2 lectures. So I hope you have learned something and you have, revised the sessions of this week 2. So if you have any questions, so you can ask. Otherwise we'll meet in the next sessions, next live session, which is next Sunday at 3 to 5 p.m. And there I will be discussing about your week 3 lectures, right? And in the week 3 we will be dealing with what? We will be dealing with scar. So we will be dealing with ductile deformations, superposed and overprinting relationships. We will see again in the next live sessions. So thank you for joining, everybody. We will meet in the next lecture. Okay, so if you have any questions, please ask. Otherwise I will end the sessions now. Okay, since there are no questions, so I will end the now. And for you, Sumit, so please go to the sessions and try to understand the basics. And if you can, if it is possible, you can register for the basic courses. It will help you. Okay, thank you.